thank you everyone for coming. So if for anybody that's watching online, what we're going to be doing today is a 2-hour workshop on an introduction to the Go programming language. So for those of you watching remotely, it's the hands-on workshop, and there may be some not so exciting segments of the video where there's a lot of dead space, but I'll try to do my best to relay questions and keep the video coherent. For everyone that's here, does everyone have a laptop? Or if you need a laptop, we have some in this cart right here. So, yeah, so the process, my plan for this workshop is to start with a short kind of presentation to give some background about myself and about the language, and like, why should you even care? Why are you here? And then we'll go through getting development environment set up on our laptops if you haven't already, and then we'll walk through some exercises to kind of learn the language itself. So let me just take a look at what I have here. I guess first, just for myself, so I can make sure I know everyone's names. If you don't mind, if we could go around and introduce ourselves. I'm Jacob. So I'm a software developer I've been doing that professionally for, I think like 6.5 years or so now. I'm involved with DevICT, which is a general developer community for all software developers in Wichita. I try to be involved with this organization as I can as well, with Women Who Code. But if we could, you don't have to give all that information, but if I could just get everyone's names to go around, start with Julia. Hi, Julia. Robin, Britton, Crystal, and then June, Karina, and then April. Okay. And then Laura. Hi, Laura. Okay. So let me go ahead and get started. So like it says on the screen, this is Getting Started with Go, an introductory workshop. Today is May the 4th. So just a little bit more about my own background. Most of my experience, so you kind of know where I'm coming from, is working with PHP. I've also worked with Ruby, Python, Node.js, and the 4 of those really aren't all that different. But mostly I'm coming from like dynamic languages, loosely typed dynamic languages, kind of like scripting languages. I've done a little bit with C and C++, a little bit with Android, some Java, just kind of playing around. And when I started working with Go, I felt at home. I felt like this was a language that really fit me, and I got really excited about programming again. I was kind of like in a rut, and then I found that, and I was like, okay, I really like this. So this is when the gopher shows up in my career. So the gopher, this is the Go mascot. It doesn't have a name, it's just the gopher. But we're big fans of it. So let me tell you a little bit about the origins of Go, the programming language. First, who here has used Go before? I know you have, Robin. Anyone else? Okay, great. So originally, the language was developed at Google by Ken Thompson, Rob Pike, and Robert Grieschmer, who are 3 very distinguished software engineers. They're responsible for a lot of important things in our history. So it was developed at Google, but it's not a Google language. Like, Google doesn't own it. It's an open source language. They're like the biggest, push behind it, obviously. But the language is relatively young as far as languages go. They started working on it in 2007, and it was publicly announced in 2009. So it's only been public for, what is that, like 7 years? And originally when they designed it, it was developed in response to some pain points they were experiencing in their own internal applications working in C and C++. So that was the target initially, was to be like a replacement for C. But the language has become very popular among developers from dynamic languages like PHP, Ruby, Python, JavaScript. for some reasons that I'll try to explain here. But what is it for? What is this, like, what would you do with Go? Mostly, you're going to be using Go to write server software, so like web app backends or APIs or some kind of web server type of thing, maybe HTTP or maybe something else. It's also great for making command line tools. Like if you're familiar with Docker, that's written in Go. Ngrok, Hugo, and a bunch of other like DevOps tools. It's really popular in that community, mostly because of the way compiling and deployment works. And you can also use Go for developing like desktop GUI applications or games or mobile apps, but that's not really its wheelhouse, and it's really not trying to be competitive there. If you're trying to make like the best video game in the world, I probably wouldn't use Go, but you could. But really where it shines is in making servers. So anything that you might use, like you might do this with Java or C# or PHP or Python or Ruby, Go is a big can compete in this space. Now let me tell you a little bit about the benefits of the language. So it's a compiled language like C or C++. So you get a lot of the benefits of compiled languages, but you don't have to pay a lot of the costs and headaches that are typically associated with compiling code. It compiles really fast. Actually, the origin myth or story behind Go was those three developers I mentioned earlier, Ken Thompson, Robert Pike, Robert Reesmer, were working on something at Google that had a 45-minute compile time. They would add some code, hit compile, wait 45 minutes, and see if it worked. And it was during one of these 45-minute compile time cycles that they started to get the idea and start talking about, maybe we can make something better. Most people don't have 45-minute compile times in C and C++ anyway, but we're talking about compiling in seconds. And actually, they've made some changes to the way compiling in Go works, and most applications went from compiling in like 1 or 2 seconds to like maybe 2 or 3 seconds, and then everyone got upset about it because they were like spoiled and used to their 1 second compile times, and now it's so slow, but it's still really fast. It's really easy to compile. You typically don't need like a make file. You just type into the terminal go build, and okay, it compiles. You don't, like, there are flags and things that you can pass, but most of the time you don't need to. Like go build is usually all you need to compile your Go application. It's ridiculously easy to cross compile. So when I say that, I mean I'm working on a Windows machine and I'm going to deploy to a Linux machine. So cross-compiling with C or C++, there's work you have to do to try to make it work before you get that to work well. With Go, all you have to do is set these two environment variables, Go OS and Go Arch, to say the operating system and architecture that you're compiling for, and then Go build will just compile for that. Actually, the Windows laptop that I'm presenting on right now, I'm using a Go program to present this presentation. It's called Present, but I don't have Go installed on this machine. Like, we're going to do that together later. We're going to walk through installing the language. So I can't write Go code. This language doesn't have Go installed, but it's all built in, and I cross-compiled it from my Mac laptop that did have Go installed. The other thing about that is the binary that you get, the final program that you get for your at the end of your compiling, it's always just a single statically linked binary. So what I mean by that is when I compile this, when I compile my program, and let's say I'm going to compile it for Linux, I put it on a Linux server. That Linux server is going to be able to run it. I don't have to install any libraries on that server. I don't have to install the Go runtime. Like, it just works. Everything it needs is baked into the binary. Now, this means our binaries are bigger. Like a hello world binary in Go is like, I think 1 or 2 megabytes. So it's all baked into it. But the idea is that disk space is kind of cheap. So we'd rather have fat binaries that have everything they need than have these smaller binaries that won't run until you install some library. So if you've ever tried to do, like on a Linux server or something, you go to install something and it's like, well, you need to install like zlib.devel, like this header file's missing. You have to install this zlib. Okay, great, you do that, and you try to install again. It's like, okay, well now you need to install this other thing, and now you need to install this other thing, and then you're trying to install all these libraries. You just want to get this thing to work. In Go, just by default, it's always single statically linked binary, which makes deployment really easy. Another benefit of Go is it has the developers made a conscious effort to make the language simple. And this is a good thing. Dave Cheney is, he's big in the Go community. He has this tweet from, this was a quote that he had at the beginning of a keynote for GopherCon India, I think last year. It says, most programming languages start out aiming to be simple, but end up settling for just being powerful. So the idea here, the difference is, well, here, let's talk about simplicity. So Go, the language, only has 25 keywords in it. C++ 11, I guess, has 84 keywords for comparison. So the language itself is very simple and easy to learn. There's not a lot to the language. In fact, you can learn the language in less than a day. There's a quote, and I'm probably going to get this wrong. Andrew Grand, who's one of the developer advocates at Google for Go, has this quote that with Go, I think it's like you can learn it in a day, you can be efficient within a week, and then you can master it within a year, because the language is easy to learn. The language is opinionated. A lot of times there's only one way to do something. I really like that because coming from more dynamic languages that kind of just developed over time, like PHP or JavaScript, there's a lot of different ways to do things, and it can be confusing, especially when you're trying to learn a language and you're like, well, how can I do this? Like I have a string and I'm trying to do some operation on it, and then you can find like 4 or 5 different answers on Stack Overflow on how you can do it. With Go, it's usually there's only one answer. For example, there's only one looping construct in the language. We only have 4. There's not for and do and while and until. There's just 4. Now it's flexible in that it can handle different styles of looping, so you don't miss while or do while. You typically don't need to use semicolons or parentheses. Braces are mandatory. Like, I don't know if you've ever made this decision looking in like PHP code. You have like an if statement, and it's like this in C2. If you have an if statement, you can put curly braces after the if statement for like the block of the condition, or you could not. And if you don't, then it's only going to execute the one line. And then this is like a decision you have to make, like should I or should I not? In Go, they're mandatory. You have to have them. And you can't. We also don't even argue about, does the opening curly brace go on the next line or on the same line? Because it's mandatory that it goes on the first line. So there is one way to do it. It's always kind of drove me nuts in PHP that I would have to make a decision in JavaScript as well. If I wanted to use single quotes or double quotes when I had a string, I had to decide. In Go, it's just double quotes for strings. Single quotes mean something else. They mean it's a different type. It's not a string, it's called a ring. Another thing about Go is it's consistent, it's predictable, it's orthogonal. So I had to, when I first read this word, I had to look it up. Orthogonal coming from math, having to do with right angles and the way when 2 lines intersect. So when we describe software like this, what we mean is if you take 2 different pieces or components of the language, they will combine in predictable, consistent ways. So as you learn Go and use it more, you'll see what I'm talking about there. Another really great benefit of Go is its tooling. It was built with tooling in mind as a first-class kind of citizen. It has a built-in testing, like unit testing framework. Benchmarking tools are built into the language. Documentation tools are built in, like Javadoc, PHPdoc. there's a plethora of analysis and refactoring tools that are available online, because the way they designed the language, they made it open and able to easily be, you can easily write tools for the language. And we'll cover some of those towards the end. Another thing that's really nice, there's a universal code formatting style, and it comes from a tool called GoFont or GoFormat. So this is the tool that ships with the language. When you install Go, it's going to also install GoFont, and it enforces a consistent coding style, and it's not configurable. You can't put in there if you want it to behave one way or another. So that means, as a result, there's no more. We don't have to bike shed over style. Like, does anyone here have an opinion? Do you prefer tabs or spaces? So like, who's tabs? Okay, who's spaces? Okay, so in Go, it's just tabs. There's no debate. But the nice thing about it, and you'll see when we get it installed, you don't have to care. You just write your code however you want, and your editor should be configured to run Go format on your code as soon as you hit save, and so it'll just automatically put everything the way it's supposed to be. That was the first time when I really started falling in love with Go, was when I installed a plugin for my editor and it did that, and I was just like, this is great. Go has an expansive standard library. So like I said, the language itself is real simple and you can learn the language within a day. But then there's the libraries that go with it for extra stuff, like to encode like images or like a JPEG or something. Like, well, you wouldn't learn all of those things in a day. But those libraries are there and they're part of the standard library and they're available. So actually, if you go to the website for Go is golang.org, and there's a link at the top that says packages, and it lists the standard library. So these are all of the things that come available with it. It's worth looking through sometime. We're not going to do it right now. Just some highlights. The net HTTP package allows you to build web servers and clients, and it's really nice. The text template and HTML template libraries, which are built into the standard library, are templating for like HTML templates or email templates or something. There's the sync package, which is nice. That helps to support concurrency. The encoding JSON package provides functions for marshalling and unmarshalling JSON to and from Go types. So like if you're making an API, which is a lot of what I do with Go, then you use that package a lot. Some other more notable features that I'll just kind of touch on real quick. It is a statically typed language. So if you're not familiar, when I say that, what I mean is when you declare a variable, like let's say I'm going to declare a variable as a string, that variable will always be a string. It is a syntax, it's an error to try to assign an integer to that variable or to assign an array to that variable or something. And this, it seems like this rigidity could make it hard to work, but it actually makes things really easy to work, because when you have the language holding your hand and basically like preventing you from making mistakes, it's just like, no, this thing is a string. Like, you can't accidentally change it to an integer later or accidentally change it to an array. So it's just really nice. The language has automatic garbage collection. So that's one of the things, some of the like FUD that people say about C is, well, but you have to manage the memory. Like you're managing memory yourself, and you have to, allocate memory and deallocate memory and be careful not to get memory leaks. So in Go, garbage collection is built into the language runtime. So it'll deallocate things for you, and so you don't have to pace. You still need to pay attention to it. It's important, but you don't have to pay so close attention. You don't have to manage it yourself. Go has an interesting take on object-oriented programming. So it forces the issue in PHP and like Java. We debate on what style of object-oriented programming should you use. Should you use composition, or should you use inheritance? Should you extend from other things, or should you implement an interface? In Go, they've just answered the question. There is no direct inheritance in Go. You can't have one class that extends another class. Instead, you have to use composition. So now what that exactly means, if you're not sure, it doesn't really matter. My point is just another example of where Go has just said this is how we're going to do things. Implicit interfaces are really nice. If you've ever worked in Java and you've had a class that implements a bunch of different interfaces, and in your code it's like you have this class and it implements interface A, implements interface B, implements interface C. In Go, you don't declare which interfaces you implement. It's just implied by the methods that you have. So it's like duck typing in Ruby, if you've seen that. And it actually makes things really flexible, because I can implement an interface from her package without having to actually like import her package or specifically like tie myself to it. As long as I have the right methods, then now I implement the interface that you've defined, or vice versa. I can define an interface, and then something from her package I can use that to satisfy this interface without having to actually, because I can't edit the code in her package. That's like a public library imported. The language has first-class support for Unicode, which is a requirement these days. There's no exceptions in the language. I mean, like, you can't throw an exception. That's just, that entire paradigm has been removed. Instead, we return error values. There's no generics in the language either. And this is usually where a lot of people get off the train. But we're not going to, it'll take too long to rehash that whole generics conversation, but it's an interesting feature. So Go is defined just as much by what it doesn't have as what it does have. Going back to the topic of simplicity, in that same talk that Dave Cheney gave, he makes the point that don't confuse simple with unsophisticated. So you have the example of you have this kitchen gadget that's designed for, like, you've seen some of these like wacky kitchen gadgets on TV on late at night on infomercials and stuff, or maybe you have this thing that can design just like for cutting eggs or strawberries or like spiral cutting zucchini or something like that. So these things are cool and they're useful, but then you have like this drawer full of all these different odds and ends of features. Whereas in Go, we've just decided to have a really nice set of knives. Just like, so this isn't unsophisticated or crude. It's actually more sophisticated because in its simplicity. Okay, so that's enough talking for now. Let's go ahead and get Go set up. So like I said, if you don't have a laptop, we have some available. Okay, so there's a link here for the setup instructions. If you're in the DevICT Slack, I put a link to it there, or you could just navigate to this directly if you go to gist.github.com and then / my username, which is JCBWLKR, which is Jacob Walker without the vowels. And then here's the notes, and we'll go through these together. If it can help to pull it up on your own if you want. So who is on Windows and who's on a Mac? Okay, just you? Okay, oh, and you're on Linux. Okay, but you're already set up, right? Okay. So the first thing that we want to do, and Britain, this is basically the same for Mac, there's just a couple of minor differences. We're going to go to the Go website. So it's just golang.org. You just see this happy little gopher here. And then right under this gopher, there's a button that says download Go. So we'll click on that. And you want to choose just choose the installer for your operating system. We don't want to install from source. We want to just use the installer. So click on the Microsoft Windows. So Go 162 Windows AMD64 MSI. So it's going to start downloading. It's going to take you to this page and it's going to start downloading. Let me know when that's done. Yeah. So the Wi-Fi, you're on Wi-Fi, right? It's make ICT. Yeah, it's make ICT all lowercase. And then exclamation mark. So I wasn't sure with the group. The Wi-Fi should be fast enough, right? Yeah. This is really so many people. So, and I've pre-downloaded them, but it's just the same. So once you get them, go ahead and run the installer. Just say yes, go ahead and run. And it'll walk you through a wizard, and I don't think there's actually anything to do on this one. Let's see. I accept, leave that as the default, and install. Okay, we'll just let that go for a second. Oh, yeah. Well, and you know, I don't know actually. Go won't have anything, but like when we get to Visual Studio Code, I don't think so either. Okay. Yeah, because I had already had stuff installed on here, and I didn't know if any of them were dependencies, like the .NET framework and those other things. So I don't know. We'll find out. If I knew any good jokes, this would be when I would throw them in there. Okay, so the next thing to do with Go, once you have the language installed, Go also has a prescribed workspace layout, how you should lay out the directories where you're going to have your code. It's called the Go path. So what you want to do, you can name this something other than projects. This is just what I'm going with for now. But make a folder, just like in your home folder, called projects. So in my case here, no, I want to do a new window. So like if I click on here, I'm on Windows 7. I think everyone's on slightly different versions, but then I go to Jacob. So here I'm in my home folder with like contacts, desktop, downloads, music. I'm gonna right click and I'm gonna make a new folder. So Crystal, what we were saying was just make a folder in your home folder called like projects or something.
Does that need to be the same path as Go?
No. Yeah, so this would be like in your home folder. Well, and you can put it like there would be fine too, or put it on your desktop if you want. Just you don't want to put it under the folder where Go is installed, which is like C Go. Install it somewhere else, like any user folder. So here, this projects folder is where all of our Go code is going to live. So what we have to do is we have to set some environment variables to tell Go where to find our Go path. So this is a lot easier in Windows 10, where the environment variable editor was improved quite a bit. But if you're prior to Windows 10 like I am, then this is roughly how this is going to go. I'm going to click on the Start menu, and in the little search bar, I'm going to just type in ENV, like Echo, Nevada, Victor. And then there's an option here that says Edit Environment Variables for your account. I want to click on that. This is where you're different. And I've already defined it, but let me just delete that one. So here, I'm going to click on New. And for the variable name, it should be GoPath in all caps, all one word. And then for the variable value, you can give it like the full path to that folder, which is probably like C:/users document something. Or what I'm going to do is use the user profile variable. So it's % user profile % /projects with a capital P. Say OK. And here, let me zoom in a bit. So like that. There's a variable called path. So not go path, but just path. We want to edit that variable so that we can tell our system where to find the programs we're going to create. And what we do is it should already have a value there. So you're going to edit it, and you want to add this onto the end. So %go path %\bin. So let me pull up my. So, I guess mine was blank, so, but it should just be like that. And then the way we can know, so then we're going to test and see if that works. So we're going to open a command prompt. We'll do all our code in an editor, but we'll run our code from a command prompt. So in our start menu, if you put in CMD, like Charlie, Michael, David, you can run this program, the black screen, the command prompt. And what you want to do is type in go space env or go end, and it's going to spit out the value of your Go environment. And you want to see that this line is correct. This go path equals whatever. So I'm just going to come around and make sure everyone gets set up on this. This is the hardest part in getting started with Go, is these variables. And then, okay. So if you're on the video, thank you for standing by. We're now resuming. Oh yes, this is being recorded. Okay, great. So we've installed Go. Great. The next thing to do is to install Git. So if you already have Git installed on your machine, great, you can skip this step. But if you don't, to install it, the easiest thing is you just go to Google and search for Git for Windows. The first thing that shows up should be this website. It's git-scm.com/download/win, and it should start downloading an installer. Yes, so we want to run this installer. Now on this one, I don't think we want to just accept the defaults. I think we want to tweak it a little bit. Oh, it really, if you do choose the defaults, it doesn't matter. What I would do when you go through this, at a certain point, it's going to ask if you want to add additional icons, and I would say yes. So go ahead and just put those icons on the desktop, unless you really don't like that. Other than that, the rest of this is fine. And I would leave the defaults. And then when you get this option where it's going to say it's adjusting your path environment, and it gives you 3 options, the default one is the one in the middle, and just leave that one as the default, I would suggest. And this is fine for the defaults, that's fine. I guess that's fine. Okay, I'm just kind of let that run. You don't have to check these. You can just click finish at the end. It's fine. Okay. So the reason we need to install Git, you don't have to use Git in your projects. I would recommend it. I really like Git, good, but Go has a tool, like kind of a very simple package manager built into the language. It's called Go Git with an E, not an I, as in Go Fetch. And it will, under the hood, use Git or Mercurial or Bazaar or Subversion or whatever it needs to based on the target system that you're trying to interact with. And like 99% of the stuff that you're going to want to install is installed via Git, so we go ahead and just install it now. And we're going to test that everything is set up correctly. So what we want to do is run this go git command. here, my screen. So it's go get, and then the URL name of a package. So go get github.com/going/lint/go-lint. And then don't include that period. But yeah, just in a command prompt. Yeah, and you can use git bash if you want, but I'm just going to use it to keep it simple. I'm going to use just this one. So go get github.com, going, lint. What? Oh, it's telling me that Git is not installed, but I think that's because I need to reopen. I think on success, it won't say anything.
Yeah.
You get like a little dancing gopher.
It's something.
Fun. There's this one, just talking about ASCII art in terminals. Yeah, that's a lot of fun. There's one where, like, so you type ls to list a folder, but you might mess up and type sl, get it backwards. So you can install a program called sl, which when you accidentally type it, it will take over your terminal, and this like train goes across the terminal for like 15 seconds, and you can't interrupt it. And it's supposed to be like really annoying to really reinforce that you shouldn't have done that.
I'm just thinking you could show your list of
Should be working. There's 10 of us downloading at once, but didn't take time. Actually, don't see it. So to go ahead and, if yours is done downloading, to test it, run this command, golint, one word, space, and then like a -h for help. Now, if it comes back and says golint is not a recognized command, then there's something broken, and let me know and I can come help you fix it. But otherwise, you should get the help text on the command. Okay, so then yours is working. Ah, great. This is done. -h. Ah, it's working. Okay, great. The last thing to do is to install an editor. You can use any code editor. You can use Notepad if you wanted to. I'm going to walk you through installing Visual Studio Code, which is like the open source light version of Visual Studio. I don't know if that's really true. It's from the same. It has the name Visual Studio, but yeah. I never tried Light IDE. I hear that it's good, but the integration I found with code, you can keep using Light IDE just fine. So to download this, so the URL is code.visualstudio.com, or if you just Google for it, VS Code, you'll find it. Code.visualstudio.com. Yeah, just once we get to the extension installation part to install the Go extension. So we want to download up here on the right. Choose the Windows downloader. Run. Don't install anything from the internet. The only thing I would suggest changing, and this isn't a requirement, but I would suggest it, is when you go through the installer, at a certain point, I would check these options and say add open with code action to Windows Explorer, file context menu, directory context menu. Personally, I would like that, but that's you. Doesn't matter for this workshop. And then get your install. Okay. So what we're going to do is we're going to open a folder in our Go path, and you're going to find actually that there should already be some things there. So do open folder, so like file, open folder, and in my case it's so I'm going to go projects, and then in that folder you created, there's now 3 more folders inside of it: bin, package or PKG, and source. So this is part of the prescribed structure for Go environments. Bin is where executables get installed. So the programs that you create and install will, like the final executable form will go into this folder bin, which is why we added it to your path. The package folder is just for the compiled assembly output forms of like libraries and packages and things. So we never work in that folder. Actually, bin and package, we never touch them directly ourselves. Then the source package is where all of the code is that we care about. So go to source, and you already have 2 folders here from when we installed GoLint. It installed these folders. So go to the github.com, and like right here under this one, I'm going to create a folder with my GitHub username. So I'm going to like right click and do new folder. If you have a GitHub account, I would use that name. If you don't have a GitHub account, it doesn't matter. Just put something here useful for you. Something besides new folder. Let me edit that. So for me, it's going to be Jacob Walker. And inside that folder, create a folder called greet, like hello. And then select that folder. That's the folder that we want to open. Yeah, so it's going to be your Go path, source, github.com, your username, and then make a folder called greet. No, I mean, you have to make that one. I just realized this is actually slightly different from the instructions in my markdown file, but whatever. So when you're here, we want to add a new file. So you can do file, new file, or Control-N, or click this little paper with the plus sign. And we want to make a file just called main.go. And that's not magic. It could be anything. That's just kind of convention that this is going to be like the entry point for our program. So we're going to call it main.go. Yeah, I did something wrong too. We need to install the Go extension for Visual Studio Code. Right. So what you want to do is open the command palette. It's the way code works. It's like a prompt where you can type in commands. And the way to do it is Control-Shift-P as in palette. And we're going to start typing in extensions, and then there should be several options. We want to choose the one that says install extension. And now it'll like do a little thing. And now on that first page, there should be an extension that says Go. So click on that one. Now it doesn't give you any real output. I mean, I guess in the bottom left corner, there's like a little icon. But you'll get this message that says Go was successfully installed, restart to enable it. So click restart now. Right, and so then when you reopen and you're in this package main, it should say analysis tools missing. When you click on that, it's going to say some Go analysis tools are missing from your Go path. Would you like to install them? And we'll say yes. Now a window should open up that says output, and it should give it a minute, but it should print some output as it's installing these packages. It's actually an open issue on the Go extension that it doesn't give you any feedback when it's done. It just stops printing stuff. So they're working on that, but I believe it's a so you can actually tweak the settings on the Go extension, and there's a lot of different options which you can read about online, but we're not going to worry about all that right now. We're only going to worry about one, which I think is the most important. So if you click File, Preferences, User Settings, it'll open up these two JSON files, JSON-ish. And the one on the right, which is settings JSON, like it has a message at the top. Place your settings in this file to overwrite the default settings. In this one, we want to add, and you can actually tab complete this as you type. So if you just go slow and then tab complete. So it's double quote, go dot format on save. And so if you start typing it, then you can hit tab. And you want the value to be, it defaults to false, and you want to change it to true. And then save it.
You want structures such that in that interim line.
Yeah, it needs to be between these two curly braces. Okay, so then once you have that in, the tools are installed, you've changed the settings. We want to restart Visual Studio Code. So just close it and then restart it. Like in my case, I'm just gonna, it's right here, click code. Yeah, I'm gonna look. Okay, so our environments are set up. So now we're going to go ahead and start writing some code. Maybe I should have started with some code so you can see it at the beginning, like so you know the light at the end of the tunnel through all of this install fest. So the first thing, Go code it has this packaging system. If you've done Python, there's like where you can like import from other packages. It's kind of similar to that. When you define your packages, if you want to create a program, an executable program that you're actually going to run, it needs to be in package main. And every Go file starts with the package declaration. What package is this file in? So we're going to create a little program, a little command line hello world program called greet. And so it needs to be in package main. So the first line of your code in main.go should be package main. Great. Now to create an executable, you also have to declare a function named main. And this function is what's going to be called to start your program. Now this function, it accepts no arguments and it returns nothing. So the signature is really simple. Actually, let me see if I can make it a little bigger. Okay, so actually let's turn off this Explorer. Toggle. There we go. Okay. So when you declare a function in Go, it's just the keyword is func. So F-U-N-C. And the name of the function, which is going to be main. And then if any arguments it accepts, this one doesn't accept any, so we just do 2 parentheses. A curly brace to open and curly brace to close. But here we have a Go program that does nothing. So we're going to do hello world, right? We want it to print something. There's There technically is, you're just not supposed to use them. So we'll just say that there aren't any, you can't print anything just in a Go program without importing a package. And so the package that we want to import is called font. It's for formatted IO. This is how you print stuff. So we're going to reference that package. So fmt. And then on that package, we want to call the function print line. So it's capital P, RINT, LN for line. We need to open parentheses because we're going to call this function, and we're going to pass that function a string. So we need a double quote. We're going to say hello, your name, and then hit save. Now, if it's set up correctly, your editor should have added this import statement at the top, import font. And so we talked a little bit about GoFont, the tool that automatically formats your code. Have you ever made a decision on whether or not you should have spaces inside parentheses, or like how many tabs or spaces should be here? So when I hit save, GoFont is like, no, this is the right way to do it. And that is so nice. There's this proverb, actually. There's this website called Go Proverbs. Rob Pike gave this talk and talked about, I think, like 12 different like little pithy proverbs about Go. And one of them is that GoFont style is nobody's favorite style, but it's everybody's favorite style because we're all using it. And so it's so nice that I can go step into someone else's Go project, and I'm just comfortable with everything that's there. And they can step into mine, and it's fine because we're all consistent across the board. Cool. So we have this program. It looks good. If you have any problems, like here, if I take off this that quote, when I hit save, because it's statically typed, it can do a lot of static analysis. It can look at your code and tell you what's wrong and point to the specific line that's wrong. So in this case right now, this line has got the red squigglies under it. It says, oh, this string literal is not terminated. Oh, I need to have a closing quote at the end. Okay, great. And then here I've got like this print line function here. And I put like, maybe I put like a comma at the end of it. I hit save. And now it's telling me like, no, like you have a problem. And so even though it is a compiled language, like I don't have to, like I don't have to like wait and compile it to get these errors. And it's not like a dynamic language, so I don't have to wait until I run the code to find out. Like I just know right away that it's broken, which is really nice. So I want to run this, and the way in code, what we're going to do, here we go. Okay. So if you right click on like the file and do open in command prompt, it should open you a command prompt that's in the right folder, which should be your Go path, source, github.com, Jake Walker, Crete, right? There's the way that you build, there's two ways to build a Go program. The one that we're going to use is called Go install. So type Go space install. If it says something, then there was a problem. If it doesn't say anything, then it worked great. So you type Go install, and then we want to run our program. So just type in greet and press enter. And it should say, hello, Julia. Hello, Crystal. We are now Gophers. We are writing Go code. I mean, so we call ourselves in the community as Gophers. So welcome to the community, everyone. We have about 20 minutes that I have allocated to just kind of go through some exercises. And then I'll stop at about 8:20, 8:25 to like quickly read through the last couple of slides that I have. And then we'll be done for today. So for the exercises, we're going to take this app and we're going to see how far we can get through it, changing it. So we've already completed step one. We want to create this program that can greet us. It can say hello and tell us our name. The next thing I want to do is change this program to optionally greet us loudly. I want to be able to put a flag on this program when I run it to say that it should yell instead of just normally greeting. So then that will be the next thing we do. And just if you leave that command window open, you're going to go back and forth between that command window and the editor. Let me close. So here's how I want this to work. Like this is where we're going to go in a minute. When I run greet, I want to be able to put on this flag dash yell, and I want it to know that we should then be yelling when with enthusiasm. So there is a package in the standard library called flag, which gives you command line flag parsing stuff. So if you wanted to read about it, you would go to golang.org/pkg or package. And here's all these packages, right? I kind of showed this for a second earlier. If you search on this page, there's one called flag, and actually the URL follows like a pattern. So golang.org/package/flag would show you the documentation for the flag package. And GoDoc is actually really nice. Some of the nicest documentation I've seen, and it's really easy to write your own GoDoc, which I can talk about later. That's off topic. But so we're going to follow this pattern that they have here on how to set some flags. So before we do it, we could do like we did before, where we let code import it for us, which was convenient. Instead, we're going to import it ourselves directly. So here in our import statement, if we add another import statement, let's say import flag, then we can use autocompletion to make it easier for us to write this code. And actually what's kind of funny, if you save at this point, it'll take it back out, that import statement, because you're not allowed to have unused imports. Like it won't even compile. So, okay, import flag. So what I want to do is I want to create a variable that is it's just going to be a Boolean, just a true or false variable. So first I have to declare the variable. So I'm going to say, and the way you do it in Go, you say var, and then the name of the variable, which we're going to do yell, and then the type of the variable, bool. So I'm going to make a variable called yell, which is a Boolean. Like this should be a Boolean variable. And then on the next line, I'm going to use the flag package. I'm going to type flag. And then when you hit dot, the autocompletion should show up with some of your different options here. And I want to choose the one called bool var. When I put an open parentheses on it, if you put your mouse over here, it'll tell you the different arguments so you know what to pass in. So this function takes four things. It says asterisk bool, it takes a name, which is a string, it takes a value, which is a bool, and then a usage, which is a string. Okay. The first one, the asterisk, what that means is it takes a pointer to a bool. So pointers in Go are not like, they're similar, but not the same as pointers in C. If you've ever done that and they're having like, you know, flashbacks or something, they're really not hard. So what we want to do is I want to pass in a pointer to my yell variable. So what you do is you put in an asterisk and the name of the variable. So what that means is the address of this variable. Ampersand. Yeah. So ampersand yell, comma, and then it wants a string, which is going to be the name of the flag. So I'm just going to put in a double quote, and I'm going to call this one yell, comma, and the next one is the value, which is the default value. Yeah. So by default, it should be false. And then for usage, this is a string it doesn't matter what you put here. This is what's going to be displayed to the user if they ask for the help. So I'm going to say something like pass -yell to make greet louder. Great. Ah. Great. So I've defined that, but I haven't, but you have to do one more thing with the flag, and this is documented in the flag package. You have to tell it to parse the flags, because like you set up all the flags that you want, and then when you're ready, you tell it to go ahead and parse them. So I'm going to say flag.parse with a capital P. So then in my code, when I say, instead of saying print line that, I'm going to make it a little different. I'm going to say if yell, and an open curly brace. We're going to do that. And then we're going to just have an else. Oh, actually, I got that backwards. This is what I should do down here. Up here, I should say, hello, Jacob. There's an easier way to write this, but I'm just introducing different pieces of the language right now. No, there's no ternaries in the language. Just good. Ternaries are bad. I mean, they're fun. It's bad for sanity. So to see if this works, if we go back to your terminal, you have to run go install again. But see how quick it is? Like, it doesn't take much to compile. And now when I say greet, it should say hello, Jacob. And if I say greet-yell, it should say all caps, hello, Jacob. And if you mess it up, you say greet-screen, it's gonna tell you you provided a flag that wasn't defined. Like, these are the different flags you can provide. Whatever. So is everyone screaming? Actually, clean this. I thought that it would do this for me. You can clean up these imports a little bit instead of repeating yourself all the time. You do. Do it like this. This is actually what you typically do. All right, so we've completed steps 1 and 2. We have 5 minutes left. We can get through step 3. So we want to we don't want to hard code our name in the system. Like, I've made a program that's good at greeting people named Jacob. Great. That works for less than 1% of the population. But it is actually a very large percentage of them named Jacob. So instead, I want to greet whatever name they pass in on the command line. I could define another flag like I did, but instead we're going to do command line arguments, which are different because they're not prefaced with like a dash something. So we're going to change this a little bit. So it's actually in the same flag package. We're going to make a variable called name. This is the name that was passed into us. And now you saw before the way I declared a variable. I said like var, yell, and it's a bool. It can get kind of tedious to have to do that every time to say I'm making a variable and it is a string. Then here is the value of the string. That is like the default way to do it. But Go also provides what's called a shorthand variable declaration, where it will infer the type of the variable based on what's on like the right side. So it's still static. It can't change after it's set, but you don't have to be so explicit when you type it. So instead of starting with the keyword var, we're just going to say name. This is going to be the name of our variable. And then it's colon equals. This is the shorthand variable declaration operator. And I could at this point just say like whatever I want it to be. Let's see, how do I want to do this? Yeah, let's do it this way. We'll make this the default value. So I'm going to do Jacob, or you do your name. So I'm making a variable called name, and it's a string, which the runtime will infer that. And it's currently has the value of Jacob over April or Karina. And then we're going to potentially change it. So what I want to do is we're going to say if and arg := flag dot, and then like this, I can tab complete this. We're going to say arg 0. And then you put a semicolon here. Then you say arg arg does not equal, quote, curly braces. So this is actually a different form of an if statement. So like here we have an if statement where it just says if some expression, and so that expression is going to get evaluated, like if yell. Here we have the semicolon, and this allows us to run some bit of code, and then here on the right of the semicolon, this is the code that's going to be evaluated. But what's interesting is this arg variable is scoped to this if block, so this arg variable won't exist past this if block. So we're going to say I want to temporarily declare a variable named arg, which should be the value of flag.arg 0. And then I want to say if that arg variable is not blank, if it's not equal to quote, this is my wrap it up alarm. In this case, I'm going to say name equals arg. I'm using one equal sign here. So what I've done here, I've eliminated the need of having an else statement. This is like an idiom in Go, like try to avoid else's. They're annoying and confusing. And so I have my value name, which defaults to Jacob. And if you pass me in an arg, I'm going to set the value of name to now arg. Now, if you save it, actually, you'll see there's a build error here. You're not allowed to have unused variables in Go. So I've declared this variable name, and I've assigned to it, but I'm not using the variable. So this won't compile. So because it's saying like this, you have this variable and it's unused. This is junk, and this is gonna like this is bit rot. It's gonna like make your code harder to maintain in the long run when there's unused code in the project. So we just don't even allow unused code to compile. So instead, I want to change this now down here. Instead of, and I could change this. See here, I'm saying like, I'm basically duplicating this twice here. So instead, I'm going to say, I'm going to make a variable called message. So message : equals, and I'm going to say, there's another, in the func package, there's these sprint or string print functions, which are very similar to many other languages. So I want to call sprintf. And the way this one works is you give it a format string, and then you can give it multiple different arguments, which will be templated into your string. So the first argument, I'm going to say hello, comma, space, %s, s as in string. And then outside of these quotation marks, I put in a comma, and I pass in name. So then if I were to do func.println message, then now this would greet whatever name I had passed in. But I lost my ability to yell, right? So we're going to do that right here before the end. What we're going to do is we're going to say if yell. So if the yell variable is passed, then I just want to uppercase the message variable. And there's another package in the standard library called strings, which has a to uppercase function. So we'll say strings dot to uppercase. Is this right? We'll find out. Okay, that's right. Wait a minute. Man declared not used. Oh wait, no, it was still building. Okay, so it's not working. So if I go look in these upper capital C, thank you. Oh, it's just two upper, sorry. There we go. And so, and that's actually, like, I was kind of messing up there, but that's a lot of how Go works, is that you write some code, it doesn't work, you get error messages right there in your editor, and you work through them until now your code works. That's great. So if I zoom out a little bit, so you can see all of this code. But here's the final form. If I move this out of the way. So if I do go install, greet Jacob, hello Jacob, greet Julia, hello Julia. Greet two B's. How do you spell your name? I don't know why I got this. Greet-L, Davis. Oh. What did I do wrong? Ah, yeah, you're right. Oh, it should be just one equal sign. So I'm not declaring a variable. Just sign values. Davis. Hello, Davis. There we go. It's 8:25. I have just a couple of slides I want to just go through very quickly, and then we can be done for the day. You're welcome to hang out as long as until they kick you out. So let me just do that. Where to go from here? Required reading. The first thing is to take the tour. I actually almost just had this workshop be, I'm just going to walk everyone through the tour. But I thought that would be extra boring, and I'd rather you have this to go with you. Anyway, the URL, it's just tour.golang.org. And what you get is an editor in your browser, and it'll, like when you edit this and you click run, it sends that code to some server, compiles it, runs it, and gives you the output. And so you can walk through and you can learn the entire language through the tour. It takes an afternoon, because it's like when you get to the end, you're gonna be like, that's it? Like, really? We're done? Oh, okay, great. Now I know go. That's very important. There's these other two documents, how to write Go code, which is actually linked when you installed it. That was like in the documentation there where it's like, oh, go read this thing next. And then this article, this document called Effective Go. These three things are required reading for all Gophers. They don't take too long. Other things you could read, there's, and this is in the Slack, you can get the link to these slides, which has the links to all of these resources. There's on the Go GitHub, there in the wiki, there's this article called Code Review Comments, which basically has, it's basically an extension of Effective Go with just extra stuff that's a good idea and you should probably be doing. You could actually, a lot of people recommend to read the actual language specification itself that was created when they made the language. It is not that long as far as language specs go. I mean, it's dry reading, like, I'm gonna be honest. Like, but as far as language specs go, it's pretty readable. It prints off on like 40 pieces of paper or something. Yeah. So there's the FAQ on the website, the Go blog, and actually all of the standard library, like that strings package, the flag package, those things that we were importing, those are all written in Go. So you can, and it's all open source. So just in your browser, you can go read the code of the standard library and see how do the Go standard library authors write Go. And most of the time, that's how you want to do it too. There's a couple of things in there where it's not quite idiomatic because it was really old packages that when they were still kind of learning and finding their feet. Another very important thing is use the tools. So if you continue with code, Visual Studio Code the way we set up today, then you're already pretty much set up for this. But it's important to use the tools that are provided, like GoFuncs to format the code. Go lint for style errors. There's a tool Go vet, which you already have, which will look for suspicious or dangerous code. There's Go doc. So when we were looking at on the website at the documentation, you can actually install the Go doc tool and just run it locally yourself, which is really nice if you're on an airplane or in a car or a train or something, that you can just have all of that documentation, and not just for the standard library, but also for any like third-party things you've installed. There's this tool called Go Metalinter, which actually, like, we've had this, it's like a first world problem. There are so many nice like analysis tools for Go that it's hard to keep track of all of them. So somebody created a tool called Go Metalinter, which just runs all of the other tools and collates all the output and tells you. And so they update that tool from time to time whenever new ones come out. So Go Metalinter is really nice. The community, Go has a great community. In the WWC and Women Who Code Slack, we have a Go channel. Please come join us. We're very nice. There's also the Gopher Slack, which is like for Gophers internationally. I think there's something like 6,000. I don't know, some big number of Gophers in there. That's a great place for getting questions asked, for finding community, for finding jobs. My last 2 Go-related jobs have been through the Gopher Slack. There's also a community, Women Who Go, which is kind of like a sub-community within the Go community at large, of just all of the women in the community have this community of support. And I have actually Women Who Go stickers here. You're welcome to have. And if anyone was interested in taking a group photo with your sticker, I would be happy to click the button to tweet at the Women Who Go community. Exercism is a great website for doing exercises. There's a monthly Go challenge. Open Wichita has a project that's written in Go if you want to get involved with that one. There's some other great resources. There's Awesome Go, which is this curated list of packages and tools from the community. Go by Example is just a lot of tutorials with walkthroughs. It's a really nice website. I should probably put it further up in my list. There's Golang Weekly, which is a free weekly newsletter that someone curates. I don't know who. Or you can, this is one thing that I felt was interesting, was you can just, on Stack Overflow, you can search for like anything, any questions tag Go, right? But you can create an RSS feed out of that search and then put it in an RSS reader, and you can see the questions, you know, every so often that people are asking about Go. And I felt, for me at least, that helped to see what kind of problems are people running into, and then read the answers that other people were giving them. And eventually, as I did that long enough, I found that I could start to answer some of the questions people were asking. The last thing about Go, try to write what we refer to as idiomatic Go, doing things the Go way. Don't take how you would do things in Python, Ruby, Java, whatever, and then try to just like translate it to Go. Because if you try to write Go like you write Python, you're gonna have a bad time. That doesn't mean forget everything that you've learned, but it just means that if you find that you're trying to do something and you're like, well, in Python I would do it like this, and I'm not finding how I could do this in Go, there's probably a different, more idiomatic way. And you can just ask, and someone in the community will help you get pointed in the right direction. It's like trying to swim upstream. Go is so opinionated on so many things that once you kind of like drink the Kool-Aid and start doing things the Go way, it's so productive. And that's it for me. Thank you for coming and listening to me talk for 2 hours and sitting through all of those installation wizards. So I will shut off. Britton, there's no questions from the gallery. Okay, let me just shut off this real quick.